Hi, this is Bernie Ziegler with an introduction to Markov modeling. For background, I recommend you watch the YouTube video Markov and His Chains by Professor Dayar from the Department of Computer Engineering at Bilkent in Turkey. The link is given here and the slides are available also. In particular, we'll discuss the umbrella model and web graph and Google matrix. In the umbrella problem, a professor has two umbrellas, one at home and one at work. When it rains, and she has an umbrella at home, she takes it with her and naturally protects herself against the rain. But then she may leave it at work. And so when she finds herself at home again and with no umbrellas, she has to go to work without any protection and therefore gets rained on. So if the probability is P that there will be rain at any time and going back and forth from home to work, what's the probability that the professor will get wet? We'll start with the number of umbrellas at the current location as our states. So there can be 0, and we'll have a state S0, 1 umbrella at the location, or 2 umbrellas at the location. So we'll have states S0, S1, and S2, and we'll have S2 closer to S0 because we're making the transition directly from S0 to 1 with a probability of 1. And then a transition from S2 to S1 with a probability of P. And a transition from S1 back to itself with a probability of 1 minus P. And a transition from S0 to S2 with a probability of P. And from S2 to S0 with the probability of 1 minus P. This represents the model that we've seen, and we're going to replicate it now in MS4 Me. And this is how it will look. As you see, there's state S0, S2, S1, and the transitions with their probabilities that correspond to the ones that we see in this presentation. And we've chosen as probability of 0.6 for P. Now let's see how we can create this state diagram. We click the state button and we can create a state S0. And we give it a time advance of infinity. Again, we create another state S2. And give it a time advance of infinity. And a state S3. Or S1 rather. And give it a time advance of infinity. So this corresponds to the states now that we have down here. Now we have to add these transitions. So we hit the arrow icon and we connect the states. Then we hit the message arrow and we have choices from which we choose the probability. And here the probability is 1. Similarly, for S2, the transition to S1 is a probability of 0.6. So we do a similar thing. We create a 0.6 transition, and likewise with the other transitions. And we have now a similar diagram, and there's no explicit transition for S1 in either case, although we could add it. But in fact, the system always computes the self transition as the difference between the sum of the outgoing probabilities and 1. So that the sum of the transitions, including the self transition, is always 1. To create the umbrella model, we hit the Markov model tab, create the Markov subselection, and in the menu we then click on the continuous time Markov radio button, enter a file name, and hit the Create Markov Model button. This creates a file, umbrella.dnl, for Dev's natural language, which has the model and which is ready to run when we hit the View in Sim Viewer. Going back to the Sim Viewer, we can hit the Run button and watch as a sample trajectory of the random stochastic model is generated. And we'll see here that we're calculating, as the file proceeds, the elapsed times in each of the states, and the relative times in each of the states give the probabilities of being in the states. So we can see that the state with the highest occupation of time, elapsed time, is state S1, and then comes a state S2, and then a state S0. And when we divide the current time, which is the sum of the individual times, by the time for S0, we get the probability of being in S0. And we see that that is close to the predicted value of 1/6. We can also create a Markov matrix model by clicking on the Markov matrix model tab and create Markov model choice, but then make the Markov matrix selection and choose as the file for the XML choice as the original file developed automatically by when we created the continuous time Markov model, and then hit the Create Markov Model to create our matrix model. This will create the matrix model, and we can run that and observe the iteration of the probability vector by the matrix for computing the steady state or long-term probabilities. And we can also obtain the an output, which is the probability of getting wet, which is very close to 0.1 10%. as predicted before, and we can see how that's done by adding an output event for the Markov model. The way we get this output is to add an output event to the model, which is done by computing the steady state probability using this function for state S0. And let's call that steady state probability of S0. And it produces a null value until the steady state value has been reached. And so if we check for that value not being null, then at that point we actually add the output, and that is the probability of rain, which is 0.6 times the steady state probability that is just computed over here. Here are some questions to tackle using MS4 Me. Let's now turn to the problem of ranking web pages using the original Google algorithm. Here is a link to a good discussion of that algorithm provided by Tim Chartier and Anne Greenbaum. Now to the Google Web Pages problem, which is that of ordering web pages according to the degree of probability that they'll be accessed. The original problem had the pages represented as states, and the states were connected by arrows or links according to the probability of jumping directly using a link from one state to the next. Some states, of course, have no links out of them, and therefore they represent absorbing states in the Markov state diagram. To handle this problem, please read the description in the video that I recommended. Now to a relatively simple solution within MS4 Me. We add a new state called jump out state and connect each of the absorbing states to the jump out state with a probability of 0.15. And from the jump out state, we allow transitions to each of the states with equal probability. In this way, we create a connected state diagram that is irreducible and has a steady state solution, which gives the relative probabilities of being in the different states. And we can order these states or web pages according to this ordering.